Cyanide, a word that sends shivers down our spines, holds a long and complex history. This chemical compound, known for its deadly potential, has been both a tool and a weapon throughout the ages. From its discovery to its various applications, cyanide's journey is a tale of scientific advancement, industrial utility, and human tragedy. Discovered in the late 18th century, this chemical compound quickly gained notoriety. Early chemists were both fascinated and terrified by its properties. The ability to bind with metals made it a subject of intense study, but its lethal nature was unmistakable. The discovery of cyanide marked a significant moment in the history of chemistry, opening doors to new scientific inquiries and industrial applications. Its notoriety stemmed from its highly poisonous nature. Even a small amount could cause death within minutes, leading to its infamous reputation. The skull and crossbones symbol became synonymous with cyanide, warning of its deadly potential. Chemists and industrialists had to handle it with extreme caution, aware of the thin line between utility and danger. Despite its deadly potential, cyanide found a place in various industries. Its ability to react with metals made it invaluable in processes like electroplating and metal cleaning. Factories and chemical plants incorporated cyanide into their operations, leveraging its unique properties to enhance production efficiency. The Industrial Revolution saw a surge in cyanide use as it became a cornerstone of modern manufacturing. Mining operations utilized it for extracting gold and other precious metals. The cyanide process, or cyanidation, revolutionized the mining industry. By dissolving gold and silver from ores, cyanide enabled miners to extract precious metals more efficiently than ever before. This method, still in use today, underscores cyanide's enduring impact on the mining sector. Its role in producing synthetic fibers, plastics, and even pesticides solidified its place in industrial processes. Cyanide compounds became essential in creating materials that shape the modern world. From the clothes we wear to the plastics that surround us, cyanide's influence is pervasive. Its versatility in chemical reactions made it a staple in various manufacturing sectors, driving innovation and economic growth. However, history also bears witness to cyanide's darker side. During times of conflict, cyanide was weaponized, causing unimaginable suffering. Soldiers and civilians alike faced the horrors of chemical warfare, with cyanide gas being one of the most feared agents. The ethical implications of its use in war continue to haunt us, reminding us of the devastating consequences of scientific advancements when misused. Its use as a chemical weapon in wars left an indelible mark on humanity. The deployment of cyanide gas during conflicts like World War I showcased its lethal efficiency. The aftermath of chemical attacks revealed the true extent of its destructive power, leading to international treaties and regulations aimed at curbing its use. The legacy of cyanide in warfare is a stark reminder of the need for responsible scientific and industrial practices. Cases of accidental poisoning served as grim reminders of its lethal nature. Despite stringent safety measures, incidents of cyanide poisoning still occur, highlighting the ongoing risks associated with its use. Emergency responders and medical professionals must be prepared to handle such cases, underscoring the importance of education and preparedness in mitigating the dangers of cyanide. As we continue to harness its potential, we must never forget the lessons of the past, ensuring that cyanide's journey through time is one of caution and respect. Cyanide, in its purest form, presents itself as a white powder. This white powder, often mistaken for something as harmless as sugar or salt, is one of the most lethal substances known to humanity. Its deceptive appearance has led to numerous accidental poisonings throughout history. The fine crystalline structure of cyanide can easily blend in with other common household items, making it a silent but deadly threat. This seemingly innocuous powder can also exist as a colorless gas. In industrial settings, cyanide gas is used in processes such as electroplating, mining, and chemical synthesis. The gas form is equally dangerous, if not more so, because it can be inhaled without immediate detection. The lack of color and odor makes it a stealthy killer, capable of causing harm before one even realizes it is present. This is where the danger lies. Its lack of striking visual characteristics makes it difficult to identify. Scientists and safety professionals must rely on chemical tests and advanced equipment to distinguish cyanide from other substances. The confusion it causes can lead to delays in treatment and response, exacerbating the potential for harm. In emergency situations, every second counts, and the ambiguity of cyanide's appearance can be a critical obstacle. This visual anonymity makes cyanide particularly dangerous. Proper labeling and handling protocols are essential to prevent accidental exposure. In laboratories and industrial environments, strict safety measures are in place to ensure that cyanide is stored and used correctly. However, the risk remains high, especially in less controlled settings where safety standards may not be as rigorously enforced. Without proper labeling and handling, it can be easily mistaken for harmless substances. This is particularly concerning in households where children or pets might come into contact with it. Even a small amount of cyanide can be fatal, and its presence in an unlabeled container poses a significant risk. Education and awareness are key to preventing such tragic accidents. This is a crucial point to remember. Appearances can be deceiving. The importance of proper labeling, handling, and education cannot be overstated. By understanding the true nature of cyanide and respecting its potential for harm, we can take the necessary precautions to protect ourselves and others. Always treat unknown substances with caution and ensure that safety protocols are followed to the letter. Some describe the odor of cyanide as similar to bitter almonds. However, this is not a reliable method of detection. Not everyone possesses the same olfactory sensitivity to this distinct smell. In fact, the ability to smell cyanide is a genetic trait. Only a portion of the population carries the gene that allows for this detection. Therefore, relying on smell alone for identification can have fatal consequences. Cyanide's taste is often described as bitter. However, I must emphasize, never attempt to taste or smell any substance to identify if it is cyanide. The risks far outweigh any perceived benefit. Exposure through ingestion, even in minuscule amounts, can be lethal. Our senses are not reliable detectors for this deadly poison. Always prioritize safety and treat any suspected presence of cyanide with extreme caution. Cyanide's lethality lies in its ability to disrupt a fundamental process within our bodies, cellular respiration. This process is vital for our survival, as it is the means by which our cells convert nutrients from the food we eat into usable energy. Without this energy, our cells would be unable to perform the myriad of functions necessary to sustain life. The disruption caused by cyanide is both swift and devastating, making it one of the most feared poisons known to humanity. This process, occurring within the mitochondria of our cells, is how our bodies derive energy from the food we consume. Mitochondria, often referred to as the powerhouses of the cell, play a crucial role in this energy conversion. They take in nutrients, break them down, and create energy-rich molecules for the cell. This energy is stored in the form of adenosine triphosphate, or ATP, which is then used to power various cellular activities. Cyanide acts insidiously, binding to an enzyme crucial for cellular respiration. This enzyme, known as cytochrome C oxidase, is a key component of the electron transport chain, a series of reactions that generate ATP. By binding to this enzyme, cyanide effectively blocks the final step of the electron transport chain, preventing the cell from producing ATP. This blockage is catastrophic, as it halts the cell's ability to generate energy, leading to cell death. This binding effectively halts the production of ATP, the energy currency of our cells. ATP is essential for numerous cellular processes, including muscle contraction, nerve impulse propagation, and chemical synthesis. Without ATP, these processes come to a standstill, and the cell can no longer maintain its normal functions. The lack of ATP leads to a cascade of failures within the cell, ultimately resulting in cell death. Without ATP, our cells cannot perform their essential functions. This means that critical systems in the body, such as the nervous system and the cardiovascular system, begin to fail. The heart, which relies heavily on a constant supply of ATP to pump blood, can no longer function effectively. Similarly, the brain, which requires a significant amount of energy to process information and control bodily functions, starts to shut down. The rapid failure of these systems leads to the swift and often fatal consequences of cyanide poisoning. The speed at which cyanide poisoning occurs is alarming. Depending on the route of exposure and the amount, the effects can manifest within minutes. Inhalation of cyanide gas leads to the most rapid poisoning. Ingestion, on the other hand, might take slightly longer for symptoms to appear. However, the delay is a matter of minutes, not hours. The bottom line is cyanide poisoning is a swift and severe medical emergency. The severity of cyanide poisoning hinges on a critical factor, the dosage. Exposure to small amounts might cause headaches, dizziness, and rapid breathing. However, larger doses can lead to seizures, coma, and ultimately death. This is why any suspected exposure to cyanide warrants immediate medical attention. Timely intervention can be the difference between life and death. While cyanide's deadly nature is undeniable, understanding its properties is the first step towards protection. Awareness of its potential presence in industrial settings, proper handling procedures, and the use of appropriate safety equipment are crucial. Education and training play a vital role in preventing accidental exposure. Knowing the signs and symptoms of cyanide poisoning can facilitate swift action and potentially save lives. Cyanide's legacy is a blend of scientific advancement and cautionary tales. While it has found its place in various industries, its lethal potential demands respect. Understanding its properties, respecting its power, and adhering to safety protocols are paramount. Remember, knowledge is our greatest defense against cyanide's silent threat. Let us use this knowledge to ensure its safe handling and prevent tragedies.